A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. I welcome you all in our today's online session. Hope you all are fine and having good health. We start today's session with the verses of Holy Quran. Hopefully my voice is clear with you guys and screen share at your end as well. So these are further the ayat of Surah Al-Maraj, Makki Surah. Okay, further, the concept of probability axioms we need to discuss in today's session. Last, we discussed the concept of probability applications in which the field probability implement we discussed, and how much probability emphasized in different of engineering technological aspects we discussed in last session. And we also discussed the concept of a dice through one time find the following aspects like sample space of this experiment and probability of outcomes, that how can we find the even outcomes, the probability of odd outcomes that we need to find in different three things that we have discussed in our previous session. So coming towards the aspect of probability, as per its axioms, rules, and types of probability. So these three aspects, axioms of probability, rules of probability, and types of probability, we need to discuss over in this concept. So axiom of probability. So the axioms of probability are the fundamental principles defined by Andrey Kolmogorov. They form a foundation of probability theory. Non negativity, the probability of any event is always non-negative. Probability cannot be a negative, so it always positive. So the normalization of axiom probability of the entire sample space. Sample space probability would be 1. So this is the concept. Probability of any event is non-negative. That means it is positive, always positive. It cannot be negative. And further, another aspect of probability of normalization, that the sample space of probability of any experiment is 1. This is the second axiom of probability. So coming towards the third axiom of probability, that additivity of mutually exclusive events. If events A and B cannot occur together, then if these are the two experiments, so further, if there are two events and A, 3 times A, and 3 times of B and B cannot occur together. So both the two events of 3 times A and 3 times B cannot occur at the same time and together as well. So these are the different aspects of probability. That is probability of A union of B, combination of two these events. How do it forms probability? Then probability of A plus probability of B uh, over the probability A integration of B. So this is that how can we find the probability of this concept. Rules of probability further, additive addition rule for any two events that overcome together the two events at the additive rule, that how can we find it, that probability of A union B would can be found by the concept like so if these are two events have A union B, the probability of these two events would be probability of A plus probability of B minus probability of A intersection B. That how it can we find the scenario, that this is the way. Multiplication rule of probability for independent event, that we need to find that if A intersection B, if the two events that independent, they are not dependent on each other, so these two events can be looks like if they are independent, their probability would be probability of A intersection B. And how it can be find that equal to probability of A multiplied by probability of B, and further the A over B, A over B. So further the concept of probability of A intersection B would can also be dependent events. So this is the probability of the concept of independent events if the two events mentioned in above expression, these are the two events A and B. If they are not dependent events, then the probability of this concept would be that how can we find further it? The concept of this probability would be A intersection B would be equal to probability of A into probability of A slash B slash A. That means B condition with A. So this condition would be dependent. So coming towards the third concept of probability, and that is complement rule. Probability of A complement can be found by equal to 1 minus probability of A into the concept. So 1 minus probability of A, that how can we find further? So probability of A can also be find by this concept. So this is the way that how can it be find by this scenario. Conditional probability. So conditional means if this can be happened, that this can also be happened. So this is the conditional probability. And it also the relevance of dependency of one event with another one. So coming towards the concept of conditional probability, that is probability of B condition with A equal to a probability of A intersection B over, or sorry, multiply probability of A, and further probability of B condition with A can also be found by the scenario. So conditional probability can also be found by this scenario. Types of probability, we coming towards the concept of types of probability, that is the classical probability based on equally likely outcomes. So equal based event and the concepts are relevance in the classical probability. So further the probability of event of A, favorable outcome, total outcome equal to the probability of A. So this is that how can it found be ways. Example, probability of getting a head in fair coin toss. If we need to get head from a fair coin toss, if we toss a coin and need to getting head from this scenario, then how this probability would be classical type of probability. Empirical experiment probability based on the actual experiments or observations formula. So number of event outcome total trials. So number of trials of any event are relevance with the probability of A. A is that particular event. So what is the example of the scenario that probability of machine failure based on past data? So we already get the data and machine can be failed. That analysis of this event can also be find of probability by the empirical aspect experimental probability. This is the second probability based type. Subjective probability based on the personal judgment, experience, or belief. Example, predicting the chance of success of a new project. So this is a subjective property, probability or axiomatic probability. So this is another aspect based on the mathematical axioms, the three axioms that I discussed in 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 previous section. Uh, Kolmogorov approach. Uh, he provide the three concepts of axioms of probability, most general and widely used in modern engineering and science. So implementation of these axioms can also be in all the aspect of engineering, management, sciences, and technological aspects and the field of engineering as well. So conclusion axioms provide the foundation probability theory and it rules helps to solve probability problems and types in last we already discussed. So four types of probability that we already discussed. Axioms are the three that we have discussed. Application probability we already discussed in our previous section. So up till now, hopefully all the things have been clear at your end. If you have any kind of question or query, you may ask in the Google Drive, Google Classroom as well, and in our WhatsApp group. If you have any kind of question, query, or difficulty, you may ask. I will answer the kind of question and resolve your queries if you have at your end. Okay, there is another aspect of probability that is explain the random variable of probability. Coming towards the concept of random variable over here, so what is random variables in probability? A random variable is a numerical quantity whose value depends on the outcome of random experiment instead of describing outcome in words. We assign numbers to them, making analysis easier. A random variable is a function that assigns a real number. So this is the main and basic definition of a random variable, that is a function that assigns a real number to each outcome in a sample space, denoted by the capital letters like X, Y, and Z. So example, toss a coin. If we toss a coin, then head can be occur. Then the outcome of that random variable of probability would be 1. And if the tail have not appeared, then this random variable would be 0. So here X is the random variable. Further, the types of random variables we discussed over here, discrete random variable takes out countable values, finite or infinite, that are the values are usually integers like 1, 2, 3 examples. So the number of heads of 3 coin toss, if we take an example, we have a coin and we toss it 3 times. If we toss it 3 times, what would be the outcome that appear? So understand it carefully. If we toss a coin, it would be probability would that no outcome would be formed. It is impossible, but it can be happened. As per the theory of probability, if we toss a coin, we know that head would become or tail would become, but as per the theory of probability, no outcome would be formed as per the policy of probability, as per the rule of probability, that if we toss a coin, no outcome would be formed. That is a zero outcome. Okay, coming towards the next, if we toss a coin, then one of head would be formed. If we toss a coin 2 times, then two heads would be formed. If we toss a coin 3 times, then 3 times head would be appear. So this is a random phenomena and randomized way, one of head, two of head, and three of head of a single coin 3 time toss example would be fulfilled by the random phenomena of probability. The number of defective items in a batch. So this is the example of discrete random variable. Probability presentation further uses a probability mass foundation, that is PMF, in which the probability X can be equal to in this way. So this copy 3 times. So I skip this thing. Continuous random variable takes uncountable values within the range, values and real numbers. So there are the continuous random experiment that the range of temperature, if we increase the temperature of a beaker, then the increasing of temperature, the outcome would be formed in this experimental aspect. That scenario would be continuous, which is uncountable intervals. Or as well, example of voltage, current and time implement as well in this scenario. So these are the temperature, voltage, current and time are the four aspects related and relevance with the example to understand the concept of continuous random variable. Probability presentation uses probability density function that is also called the PDF, which is called f of x. Probability over an interval can also be represented in this form. That probability of A that is less than 2x and x which is less than 2b. So these are the two random phenomena, random experiments, random outcomes which can be formed in this aspect. Important concept probability distribution describe how probabilities are assigned to values of random variables which are discrete. So discrete aspect of outcome can be come from PMF, probability mass function, and the continuous outcome of concept of probability in PDF, probability density function. So probability density function provide the continuous aspect and the discrete aspect is related and relevance to the PMF, probability mass function. Expected value, that is the mean value in random probability based the random phenomena. Average value of random variable, that is the discrete one. So that how can be find by the scenario, which is that how can you find the mean? Mean or expected value can be express E of x equal to summation of x into P of x. This is the concept of discrete expected value related to the mean. Continuous value, which is E of x equal to integral x f of x into d of x. So this is the way that how can we find the concept. So it is the concept of continuous, then integration of sign can be implemented over here, and the summation of aspect, the sum of aspect in continuous, and in discrete summation aspect would be related to the summation of sign, that is also called the sigma. So the third concept in probabilistic analysis of random variable, that is the variance and the standard deviation, measure the spread and variability. So variability that is mentioned over here. So that how can we find the variance of this concept? Hmm, so variance can be found over by the scenario, and the standard deviation, that is called the SD, sigma. So how can we find the standard deviation, that is called in short SD? Square root of that variance, the value variance that we found by the scenario, that expected value of mean x of random variable minus the mean value, taking the square root of that value, that expected value is called the variance. And taking the square root of that variance, we got the value of SD, that is the standard deviation. So the concept of example in engineering, all the aspect of random variable in probability. So what are the examples in engineering? So engineering are electrical engineering, noise and signal modeled as random variable. Software engineering, in software engineering, number of bugs per module. Mechanical engineering, the life of components can further be concept of random aspects related relevance example, because the life of a component is the random phenomena. Telecommunication is related to the signal strength variation. Coming towards the conclusion of this aspect, the random variable convert random outcomes into numerical form, making it easier to analyze uncertainty, model real-world systems, perform statistical calculations, and they are fundamental in probability statistics and all engineering field. Up till now, anyone of you, if have any kind of question, query, or difficulty, you may ask. I will answer the kind of concept and resolve your queries if you have in your mind. Or if you have no kind of question or query or difficulty, we end the part of this session over here. And in further next session, we continue with the new concept of probability and aspect relevance of some real world example to clear and understand the concept of probability, which is implemented in the field of engineering, science, and technologies as well. So hopefully all the concepts have been clear at your end. But if you have any kind of question, the platform of Google Drive, Google Classroom, and WhatsApp group accessible at your end. You may ask your queries and question. I will answer all your question and queries over there. Up till now, hopefully all things been clear. So I ended today's session over here. Thank you very much.